Welcome to the Recharge Zone podcast. I'm your host, Brent Doty, joined by my co-host, Ann Margaret.
Hi, everyone.
And we have a very special guest today, Mark Hamilton.
Hello, everyone.
Hey, Mark. Mark is the Executive Director of Aquifer Management Services. It's a division within the Edwards Aquifer Authority that hosts aquifer science research and modeling, data management, and aquifer sustainability. Mark, today we want to revisit a topic that we talked about a few years back, actually, just after the pandemic, which is all about the Edwards Aquifer Authority's Field Research Park, or FRP. So if you hear us saying FRP today, that's what we mean, Field Research Park. So Mark, back when we talked several years back, we had been working on some of the land management practices, including the berm and swale, some of the methodology to study them, but that's kind of where we left off. I'm sure a lot's happened since. Do you want to recap anything, any significant event that's happened over the past few years?
Sure, and thanks, Brent and Ann Margaret, for taking the time to have me on today. So we've done a great deal of work at the FRP since we acquired it back in, I always think of December 2019, but we technically acquired that property in November of 2019. And for those who don't recall, that's our 150-acre property out on the northeast side of Bexar County along Cibolo Creek, where we've been conducting groundwater-related research now for about 5 years. So early in the process, we installed, some people call them conservation terraces, berms and swales, same thing. The idea there being to slow down runoff water and capture sediment and organic debris and keep that on the land surface, and then water that does run off would be ideally a bit cleaner and make for cleaner recharge when it hits Cibolo Creek, which in that area is a Edwards Aquifer recharge zone component. But we've learned so much in the 5 years, and one reason we've learned so much is we just have this amazing team of people that are really invested in doing great work and finding new and better ways to unlock some of the secrets about the aquifer, and we have the capacity to do that just because we have that property. So after we did our berm and swale installations and we began to start to monitor those things, we did the LiDAR work, and I think we talked about that last time. In addition, we installed these boreholes where we can look at basically what I would call beta zone moisture or unsaturated zone moisture, using our tool, a nuclear magnetic resonance tool, or NMR. And that data has been really interesting. That the biggest problem we've encountered really is related to the drought, in that we have not had but one or two significant rainfall events since we installed the borehole. So it's really difficult to collect data when you don't have any rainfall.
That's right. So our last podcast was in 2021, and just shortly thereafter is when this began, right?
That's right, yeah. And based on some of our modeling work that we've done internally, this particular drought happens to be the most intense drought on record. So I think that's pretty telling in terms of how difficult it's been to collect data related to rainfall events. But, we've done some other work out there that I think will be very meaningful over time. And we've started experimenting more with, we call them rock structures. So just using rock, native rock, in areas where we're suffering from erosion or scouring of channels to slow down runoff and capture sediment, and then using seeds from native grasses and other plants to populate those areas that are capturing that sediment. So you establish roots in the ground, and you really do a much better job then of slowing your runoff and stabilizing all those areas where you're not losing your soil and putting it into the creeks where we don't want it. So I think one of the things that, at least for me, has been fascinating is starting to unravel this relationship between different types of structures, whether they're earthworks like a berm and swale, or if they're a rock structure, and then the relationship with the native grasses and native vegetation, even the woody vegetation. That's all so incredibly important. And I think as we go through this process and learn more, and hopefully we start to get some rain events to measure, maybe we'll start to understand easier, more cost-effective ways to really help the landscape become healthier, get healthier soil, reduce your erosion components. it takes time. That's the hardest part of every good research project is it just takes a long time to get good data, analyze that data, and then draw some conclusions from the data that you collect.
Why is it so important to keep the soil on the land?
Well, one of the problems with our landscape in general is we've lost a lot of soil already, and soil is really that sponge that lays at the top of the surface that infiltrate or allows water to infiltrate into the subsurface more slowly. It holds water for your vegetation. The healthier your soil is, the less brittle your landscape might be in a drought. But also, soil has an amazing ability to capture things or attract things that you may not want to stick to it. And if you allow that soil and all that debris to accumulate in your recharging streams, well, one of the things it can effectively do is it can clog up some of your recharge features. It also kind of degrades your landscape where your vegetation becomes less healthy. There's less media there to hold moisture for your plants, and then it becomes self-ramifying. The more you lose, the more brittle your landscape becomes. The more brittle it becomes, the less healthy your lanlandscape, and it just
like snowballs. A domino. It's like
a
domino kind of thing.
Right.
So if you didn't have these land management practices and these things that were being done, what could that land look like?
I guess it depends on a lot of other factors, right? So if you think about the basic principles of soil health, some of those principles involve things like keeping your soil shaded, keep it covered, and typically that means having vegetation growing on it to keep it cool. It also means another basic principle of that is not disturbing your soil, because once you disturb it, you destroy the roots and you create a wound, if you want to think of it that way, where you start to bleed some of the moisture out of your soil, you start to destabilize your soil, and you start to lose your soil. Soil takes a long, long time to build. There's an old NRCS, National Resource Conservation Service poster at the FRP that we put on the wall some time ago, and it talks about, in general, it takes about 100 years to make an inch of soil.
That's crazy.
I'm sure there are exceptions to that. I'm not a soil scientist, so I can't speak in depth to that, but it's an interesting thing to think about. So you want to take care of the soil you have and let that be the sponge that provides that filtration and infiltration component into the subsurface on the land.
Especially over the recharge zone, right?
Right, exactly. And I think, especially in light of what we think may happen with climatic variations over the coming 50 years or 100 years, the more we can do to remove some of the brittleness from the landscape, the healthier our vegetation will be in the long term, which just leads to a healthier climate, healthier planet, healthier ecosystems. So all of these things are related. We do our work in terms of how does this benefit groundwater, but there are all these other ecosystem services that go with that work that are really important. So it's interesting to bear those things in mind.
Yes.
Yeah, that's what I've kind of learned throughout this drought. Yes, it's been hard to research without significant rain events, but maybe we're learning about how we can make landscapes more resilient and resistive to drying out, as well as recharging when there's enough water. Maybe we're making them more resistant to just becoming dry.
Right. When interesting thing to look at when we have these kind of out of the blue big rainfall events that we tend to get in this part of the world. If you look at that runoff, if you have a unhealthy landscape, poorly vegetated, a lot of bare soil, what you'll see in that runoff is it's really full of sediment, right? It looks like chocolate milk. Well, you really don't want that. You don't want to transport your soil from the land to the stream beds. That's not where it belongs.
So in a way, can it kind of clog recharge features?
I think it could over time, especially some of the smaller ones, right? And we see those at the FRP. We see these little small openings that are probably maybe 2 or 3 inches wide or long, and they don't take millions of gallons of water individually, but collectively those things probably take in a lot of water. And I think the better job we do of keeping sediment and debris out of the creek beds, probably the healthier those features might be in the long run.
Wow. And in doing that, since the sediment is not making that chocolate milk kind of water, does that mean faster recharge?
I would say not necessarily, but it sure makes for cleaner recharge. You know, karst systems don't do a very good job of filtering runoff. So ideally, we would like to see the cleanest runoff we can
entering
have.
in, yes.
Because that's another component to the sustainability thing. You know, that you're doing something to improve water quality over time. And you know, it's likely to take some years before we can start to quantify the benefits to recharge, but at an observational level, we certainly see that our runoff is cleaner downstream of our different practices that we've installed, and that's a benefit. We know we're doing some good. Have we quantified it yet? No, but assuming that it starts to rain again soon, we might.
Yeah, I know. Well, back a few years ago when we had you on, Mark, we just talked about just getting our feet wet into figuring out how to monitor and evaluate land management features. Since then, we've had other scientists on, Logan Schmidt, Thomas Marsalia, and others talk about some of the experimentations and methodologies that we're using now. So we have not only just NMR, like we talked about, nuclear magnetic resonance, but also resistivity. So it's electrical resistivity tomography, or ERT, which Logan talked about in another episode. We have our eddy covariance tower, which we've talked about. We have a new Texas Mesonet tower, which is a really high resolution weather station. Can you talk about just that, the evolution over time of all these different methods and how that's going?
Sure. And that's been one of the most exciting things to watch is we continue to populate the landscape with really high quality instrumentation, and that's really the only way we're going to ever quantify anything, right? Better understanding of the water balance over time. So measuring evaporation or evapotranspiration, understanding how moisture or water move through the subsurface in a way that we've never understood it, being able to measure that and quantify that. You know, another thing that we recently installed, and Thomas and Brent both, you guys kind of took the lead on this. We installed weirs in the top of the watershed so that we could begin to understand more about runoff dynamics in these ephemeral stream beds, where maybe a lot of the recharge that is diffuse in nature takes place in these little ephemeral stream beds, but they're not well quantified. They're not well documented and really not that well understood as to how they move water. How long does water run off in a stream bed that hasn't been impacted by anthropogenic events? Do you have a longer duration runoff period, you know, with kind of a slowed recession curve versus a real quick recession curve on a stream channel that doesn't have any vegetation? So we need to understand those things too. So I sometimes tell our guests at the FRP, if we can get to the point where we can kind of parse out what happens to every drop of rainfall that comes down, where does that drop go? How does it get parsed out? How much goes to diffuse recharge? How much goes to discrete recharge? How much of it is lost through evaporation and or transpiration? We can get there, then I think we can start to unravel more about how the aquifer works, especially in terms of recharge and water quality too, and then translate that understanding out to other basins within the aquifer. And it all leads to being able to manage the system better, and it leads to a higher degree of sustainability. The more we understand, the more sustainably we can manage the system, and the more we can do to augment really the water quantity and quality over time.
The thing that I find so fascinating about the research that you all do is I know the land was essentially inherited. So, you know, people do things to their land, maybe not knowing the ramifications of something that can happen down the road, right?
Right. And it is really interesting because as time goes by, the parcels of land in the state, and not just in Texas, but really everywhere, they become more fragmented. And you may have a high density development on this fragment or this parcel, and next door you may have very degraded landscape where it hasn't been managed well for a long time. So it may be lacking vegetation. It may have a lot of open ground. It may have active erosion points. And then you may have a really well-managed landscape next to that where people have done rotational grazing and they've worked hard to establish a lot of native grasses, and they've maintained good woody vegetation on the steep hill slopes. So you see these really healthy landscapes next door to a landscape that is suffering from significant erosion, which is next door to another landscape that has really rapid runoff from highly dense development. So understanding how to do things to help nature recover from all these different events so that we maintain our water quantity and quality in the system is really kind of where we're going with this, right, over time. So the history of the land and how it's used is really fascinating to look at and try to understand, but also trying to understand where's it going over the next 50 years, what's going to be the biggest impact on water quality over the next 50 or 100 years, and how can some of the practices that we're trying to understand better mitigate some of that in time.
And so correct me if I'm wrong, but the land, like how it is now, is obviously due to environmental factors of things that have happened. Like you said, development happens up, a little bit, close to some rural land. And so essentially the goal is to try to get the land back to what it used to be.
In a sense, but I think if you look at the history of the land and begin to understand that there are certain things that have impacted how the landscape has evolved over the last several thousand years or more, we'll never go back to some of that. There was a time where we had a lot of big grazers that were, they had a big impact on the landscape. They probably helped to keep some of the woody vegetation in check. We also, according to a recent presentation that I watched with the Texas A&M AgriLife folks, I didn't realize until I saw that this area of Texas used to burn pretty frequently on its own. And that probably had a lot to do with keeping woody vegetation in check. And a lot of the native vegetation is very well fire adapted, so it probably kept that vegetation healthier. Well, we don't do those same things now, right? It's not really feasible to let fires burn. It creates other issues.
Yes.
So what can we learn about the landscape where we can kind of help the landscape evolve back to where it wants to be without introducing those factors or disturbances, if you want to think of it that way, that used to be common. So that's a bit of a challenge, right? If you leave your landscape completely alone and do nothing to it, it's likely to get a lot of woody vegetation growing on it pretty quickly. And that may or may not be a good thing or a bad thing for soil stabilization and for infiltration, but that's certainly unlikely. It's certainly unlikely that that's what it looked like 1,000 years ago, right?
Yes.
It was probably these little mosaics of tree mottes and then a lot of cedar in your hill slopes and hillsides and the valleys. And you probably had quite a bit of grassland that was all kind of naturally managed by grazing animals and likely some, episodic fire maybe every 4 or 5 years. Well, we don't have that now. So what do you do to kind of help your landscape? And a lot of this is pretty new to me because this is not historically within my background, right? I studied geology in school and I did not study land management or range management. So a lot of the staff have spent a lot of time on their own trying to educate themselves more about this sort of thing. And I think that's just another part of what makes the FRP really interesting is you have so many people who are highly engaged that have spent a lot of time on their own.
Yeah, lifelong learners, right? Yeah.
And they're motivated, they're engaged, and they're making a difference. So I would credit the successes that we've had to the staff that we've got. It's a team of people that are really into what they're doing, and I think they're to be commended for that.
Yes. And speaking of teams, y'all have partnered with agencies and organizations, right, across the state of Texas and probably beyond.
We have certainly welcomed people from all over, if you will,
Yeah.
to come out and talk to us, and we talk to them about what we're doing. We learn from them, they learn from us, and I think that's a really healthy relationship. We've also engaged researchers to help us with things that we don't have background in. For example, UTSA is doing a lot of soil health analysis for us. We've been talking some with the folks at Texas A&M about understanding more about how the different woody vegetation captures rainfall and how does it translate that moisture into the ground or not. There's a number of things that we realize we need to contact external resources to gain another level of expertise so that we can move this research forward so that eventually we can start to quantify how these different practices that we've installed work. And, it'll be fun to see what we find out. I'm hoping that we can kind of optimize a set of practices over time so that we know, practice A, B, or C does these things and it costs this much, and we can identify areas perhaps where we could install some of those practices for a very few dollars and have a really big impact.
That's amazing.
That was going to be my next question. So we've talked about basically 2020 to 2025, putting all these practices in, identifying methodologies and using them to study these practices, and observing the site through this prolonged drought. But where do you see the FRP going in the next 5 years into 2030?
Well, that's a great question. I think the FRP is just this amazing multi-purpose venue. It's certainly become our hub for groundwater research and groundwater science, and that's really important, right? We haven't talked about the FRP is also being used to better understand the relationship between the Trinity and Edwards Aquifer, and how do those two aquifers communicate with each other. But the FRP has been extremely valuable as a resource for building relationships across the region and really throughout the state. We've literally had people from all over the world, but dominantly people from all over the state, come out and talk to us and learn about what we're doing and why it's important. And I think any successful venture requires building good relationships and building rapport with people so that you don't work in a vacuum. And I think over the next 5 years, we will probably grow all of that significantly. We've spent the first 5 years getting our feet under us, if you will, and learning more about different practices and how we might instrument those practices and begin to quantify them. But we've also learned a lot about how to engage others, and I think that's going to be one of the big focus areas in the coming 5 years. And I'm very excited about that the possibility of engaging with people, engaging some of our Edwards Aquifer Conservancy component with some of those people so that maybe there's some opportunity for external funding to further this research. And maybe in a perfect world, maybe we could accelerate some of that research with external dollars.
And, through a series of fortunate events, we've acquired a conservation easement in the form of the Dissinger Ranch and a research property in the form of Maverick Ranch.
Right. Those are also really interesting components to our groundwater science because, Maverick Ranch is on the contributing zone, almost adjacent to the recharge zone. It's within a few miles of the recharge zone. And I think from a groundwater management perspective, we need to invest resources in understanding more about the contributing zone because what happens on the contributing zone certainly impacts what happens in the Edwards Aquifer. But we haven't had opportunity to do a lot of research on that, and I see this as that opportunity, so I'm very excited about that.
Yeah, maybe a lot of the lessons learned at the Field Research Park can be extended to other properties and places over the aquifer.
Right. That is part of the hope, and I wish that we could snap our fingers, so to speak, and quantify these practices and move on to the next step sooner than later. But so far, for whatever reason, the rainfall patterns haven't cooperated much. But I think they will. I mean, sooner or later, it will rain again.
Yes. You know, they say the best things in life take time. So
That's what they say.
And actually, we're ahead for 2025. We've already met our annual quota for rain.
That's
our
true.
annual average. So maybe this is a good year.
Maybe so. But according to some of the senior scientists on staff, we're still 60 inches behind for the past 3 or 4 years.
Making up for those past several
Yeah.
years.
So
22 and 23 especially were really, really bad.
We all remain hopeful. How's that?
yeah.
Yep. Consummate optimists. Well, Mark, we really appreciate the conversation and the update on the Field Research Park, and we'll continue to learn more. There will be upcoming articles about it and the news drop, and so we look forward to hearing more about it.
Thank you so much.
Well, thank you guys for having me, and let me know when you want to talk about the FRP more. I'll come back and visit.
All right, y'all. Well, thank you for tuning into this episode of the Recharge Zone podcast. Be sure to subscribe to our podcast on your favorite podcast hosting platform. And if you have questions, ideas, or things you would like to share with us, feel free to reach out to us by emailing us at rechargezone@edwardsaquifer.org. And don't forget to follow us on Facebook, Instagram, LinkedIn, X, and YouTube.